This is the transmitter schematic. This is the portion that is the physical stack light. I will try and make this documentation public, most likely via an Instructables blog or a downloadable PDF on the YouTube video, but for now all that will be available is for a screenshot. The first thing I want to note on this schematic is the NRF24L01 in the top left hand corner. If your build or the stack lights you're building does not have any need for radio or wireless communication, you can leave this off. But if you're going to do anything with wireless transmission of data, you'll need to include this. So this is an NRF240L01. It's a basic SPI module. So the pinout is the same as any other SPI module. You have S clock going to digital pin 13, MISO to digital pin 12, and MOSI to digital pin 11. The other two connectors on here for data are CE and CSN, and I'm using digital pins 8 and 9 on those respectively. However, you can put those anywhere you want. This board uses a 3.3 volt power supply coming directly from the Arduino, and then of course ground is tied in with the Arduino and everything else. A note here is also use a capacitor that's not included on the breakout board between your power and ground. It helps a lot with these NRFs. They seem to have some finicky situations if you don't include those. Beside that, we have the 3 switches that will control our different colored lights. We will be using the onboard pull-up resistor via the hard-coded on the Arduino sketch for these, and so one side of your switch will end up coming into a digital pin and the other side of the switch will be tied to ground. For these switches, never mind the third leg in the picture. That's for the onboard LED, which is not necessary. Going on to the LED strips, those are going to have 3 different strips, one for red, one for yellow, and one for green. The strips are 5 volts for these, so I'm going to tie those into the Arduino 5 volts, and then the ground obviously tied to ground. For the data in or data lines, I'm going with digital pin 2 for green, digital pin 3 for yellow, and digital pin 4 for red. So once you have all this plugged in, you'll use all but 3 of your digital pins. You will not be using digital pin 10 or 0 or 1. For powering the board, I have a 12 volt power supply listed here, and that's a common connection going to VN and then also to ground. If you have a worry about the LED amp load on the Arduino, I can say that I've used upwards of 100 to 110 LEDs from the Fast LED library off an Arduino Uno module and not had any type of negative effects, but was also not running them at full brightness. So considering that there's only about 20, 30, 40 LEDs at any given time that'll be lit up on this module, you should be fine just to use the Uno as the 5 volt power supply as well. But underneath this, I've got a data table for the connections if that's easier for you to look at. So this is color coded. At the top we have the RF transmitter. Here you can see on the left hand side you have the pins or the labeled outputs of the RF transmitter, and on the right hand side you have the places those all plug into. And then underneath that you have 3 spots for the switches, which is going to tell you which of the 1-2 legs, where they go. And underneath that you have the LED strips, which once again tells you the ground 5 volt and then the data in and what pin that's coming from. And underneath that you have a 12 volt power supply just for having everything labeled, but this should be pretty obvious. Alright, I don't want to go into a whole bunch of details for these codes. We're going to try and go through it fairly quickly. I don't want to make the video too long, but let me adjust this real quick. Alright, so essentially this is the transmitter code. So you will have one of these for each of the transmitters, each station. The top is just defining some libraries. You're setting your LED brightness here. You're declaring how many number of LEDs are on each of them, on each of the transmitter stack lights, and then you're calling out the 3 data pins you want to use for each color. So for my case, it's 2, 3, and 4. Here we're setting up the variables we'll be using later and applying the amount of LEDs to it. This is setting up the CE and CSN pins for the RF radio. This constant byte address is the channel that you're going to use for the radio frequency transmission. So between the transmitter and the receiver, they all must have the same channel. This is a variable that's going to be used to see if more than one switch is turned on for an error signal. Then we have these two variables, last light and new light, currently set to 6 and 7 here. But essentially what's going to happen is as the transmitter consistently reads all of its switch states, it's going to, at the beginning of each time it does the check, it's going to compare last and new, and if they're the same, it's not going to do anything. But if last and new are different, then it knows that it needs to send a RF signal out. Setting our baud rate here. This is just setting up your RF antenna. So, begin, you're open the writing side for the transmitter, you're setting a max level, and you're going to turn off listening because you're just transmitting. Here we have some fast LED variable lines of code. So this is just going to tie the variable to this, what the variable is being called here. Then we have the 3 input pull-up pieces of code, the other 3 switches, so 5, 6, and 7, that will be actually connected to the physical buttons. Then we move into the loop portion of the code, so this portion runs over and over again, and essentially what you have is, multiple if statements. And so what it's doing is saying here, if it's reading just the green light switch is on and the red and yellow lights is off, then it's setting new light equals to 1. So this is going back to what we were talking about earlier. It's saying that new light is the new variable, and it does that for all of them. So it's checking for green, yellow, red, off, and then also the total lights is equal to the addition of all of the switches. So if the total lights is greater than 1, it's going to set it to the error state. And then here I've got 2 print lines, which is just for debugging. So here's the part we were talking about. If last equals new, do nothing, and then print do nothing into the serial comm so that we know that nothing has changed as far as the status of the switches. And if something doesn't match, then we hit the else portion of this. And what it's going to do is it's first going to read all of them together to see if it's in error, and if the total lights or only one switch is clicked on, so less than or equal to 1, it's going to go ahead and do some things. Once again, you have essentially 3 identical pieces of code. I'll go over one just to show what it is. So once again here it's saying, hey, if the green switch is on, the yellow is off, and the red is off, then make this value 21. This 21 value in my code stands for station 2 green light, which we covered in the PowerPoint portion of this video. And all you're going to do is write the value you make here. So this is going to send that value, that 21, to the receiver, and it's going to have code to know how to do that or how to handle it. And then we're going to print green to the serial comm just for debugging and so we can see what's going on. And then we're going to run this private sub, which is at the bottom, or private void I should say, turn on green, which is simply going to turn on the green, the LEDs to a green color. So you've got essentially the same thing here 3 times in a row. One's detecting if just green is on, just yellow is on, just red is on, or if they're all off. And then if there's an error here, once again we can see it'll print the line of error, it'll write that value 4 to it, and then at the end it's going to reset the variable total lights to 0, and it's going to set last light equals to new light. So once it hits its code and it runs, when it goes back to the top of your loop to run again, then it will not consistently keep changing over. And I have a 3-second delay in my code because I don't want to bombard the receiver with status changes, especially in the real world. If you are an operator and you're clicking lights on and off, then you might accidentally click something wrong, and 3 seconds is a good amount of time for them to correctly input what they want on the actual light. And at the very bottom here, very straightforward, we have these 3 private, or a few private voids. They're exactly as they're described. All it does is turn on green and turn off everything else. It's very important to not forget to set the yellow and red to black or off, and so that's what all these are, and that's the gist of this code. This is a schematic of the receiver module. You should have one of these for all of your transmitters. So this will be connected to a computer if you're going into the data analysis portion of this project. It will connect via serial comm. This unit also has the RF transmitter and receiver. In this case, it will be only a receiver. And this is also, once again, a standard SPI connection with a 3.3 volt power rail. On here, notice this is an Arduino Mega, so your SPI control pins are 50, 51, and 52 instead of 13, 12, and 11 like on an Uno. And the reason I use a Mega in this project was I had so many transmitter stations that I needed the digital pins. For LED strips on this module, you're going to have one LED strip per transmitter. So for this example, and in the example code I'll post on GitHub, the only channel 22 or digital pin 22 will have one station. And if you wanted to add more stations, what you would do is simply add another LED strip, connect it to 23. You could add another LED strip and connect it to 24. So you'll have one transmitter per digital pin, and you can do that anywhere from 2 up to 49, and however many stations you have. And once again, I've got an actual data table at the bottom to show it in a table format. And once again, on the left hand side you have the module connections, and on the right hand side you have the Arduino connections. So you have the SPI radio frequency receiver, and you have the LED strip stuff here, as well as a special note for attaching the serial comm to a PC. If you are not going to do any data collection via a .NET app or Python, you can leave out the connection for the computer and just have everything else. This is the receiver code. So once again, I don't want to spend a whole lot of time on this. Very top is just including libraries. You're setting the number of LEDs on each strip of the receiver, and you're defining the data pins that are going to be used per station. So here you've got digital pin 22, so I'm going to write a data pin to that, and you need one of these defines per transmitter. So if you had another one, you'd come down here, and I'll just comment this out, but you would have define data pin 23, 23, and you would do that for each of the stations you have. Now this right here is just once again adding the number of LEDs to the LEDs variables that you're creating. You'll need one of these per station. We're declaring our CS and CSN radio frequency pins here, as well as the RF channel. These two variables are used to, because if you have stations, it's either going to be, if you have stations 1 to 9, it's a 2-number signal that your receiver is going to get. Station 1 green is 11, 1 yellow is 12, etc. But if you get to station 10, then all of a sudden you have a 3-number variable. And so we have some code in here that's going to break it apart and see exactly how many numbers is on that it's receiving, so the code knows how to handle that. And it'll if it's a 2-number, it'll toggle this to 1, and if it's a 3-number, it'll toggle that to 1 and turn the other one to 0. Set your baud rate, add the data pin LED, fast LED variable. You will need one of these lines per transmitter station. Then here we're going to go ahead and turn on our radio frequency module, start listening, and set our power level to high. Then this is used for debugging. You probably just delete the code out. You don't really need it, but it's essentially an LED to know if you have data going through during flashing your Mega. So here we're saying if radio is available, then do some things. If the radio is not available, just skip all the code. We're setting this value here to nothing, and we're going to read that value. So whenever we read that value with this radio.read line, it's going to give us this value, and then we're going to manipulate or look at that value to know what we want to do. So here is the code we were just kind of discussing. If it's a 2-number or a 3-number station. So here you can see this should actually be 9, and this should be 10 to 999, but it still should work. So, well, no, that's right, because it's technically two numbers. So it's just declaring if that value is coming from a single or a dual digit station. Station 1 versus 12, for example. And then here is an else to catch if something is going wrong in your code. So we're only going to talk about one station. My code has, I think, 20 something stations on it, but we'll just, for practice purposes and for this, we're just going to do one. So here we're saying that 2num is 1 and 3num is 0, so our receiver received a number like 21, 31, 51, etc. It's going to assign value A to that value from what the radio read, and then this line of code is going to get the tens number, and this is going to get the singles number. So if it's 21, for example, or 12 or 11, Q is going to grab 1, W will grab 1 for 11. For 12, Q will grab 1 and W will grab 2. And that way we know exactly what we need to do with our transmitter as well as on the light, or the receiver, I should say. So here you can see if Q equals 1 and W equals 1, this is reading a station 1 green light signified by the number 1. So we want to go ahead and run this private void, which is at the bottom. It turns all the lights associated with that station green. And then it's going to print this 1G to your serial comm. So your code on your computer will read this as station 1 green light, and you can have it do whatever it wants to do or however you want to handle that. And that's all of this right here. And then there's nothing in here because I didn't want to put a 3-number station in, but this is essentially, this else if right here is directly correlating to this other if statement. So here if we had a 3-number, so like station 10 green light would be 101, where you're doing the same thing as before except we're breaking down 3 numbers. So we're getting a station, tens, and singles, and then on the 100th value we're grabbing the light. And then, but right down here you would actually write in the same, all this right here, except that if Q equals 1 and W equals 1, or I should say if Z equals 1 and X equals 1 and C equals 1, then do something, and you would roll through it just like you did here. And then further down here are the simple LED code. So this will just turn on station 1 lights green, station 1 lights yellow, etc., which you saw earlier up in the code.